Imagine the sheer ambition of it. You are an architect in ancient China, and the emperor has commanded you to build a palace complex so vast it becomes a city within a city. A labyrinth of audience halls, temples and private quarters, all topped with sweeping, impossibly heavy roofs of glazed tile. He demands grandeur. He demands beauty. He demands it to last for centuries, standing strong against earthquakes, howling winds, and the relentless march of time. And he gives you one more, seemingly impossible instruction. You cannot use a single nail. No metal fasteners, no screws or bolts. To our modern engineering minds, this is a paradox. It defies everything we think we know about strength and permanence. How do you build the impossible without the most basic tool of construction? The answer is a story of genius that was lost to time, a secret hidden in plain sight within the very bones of China's greatest structures. This isn't a story of what they built, but how they built it. It's a story of wooden puzzles, of seismic secrets, and of a philosophy so profound that it didn't just create buildings, it created living, breathing entities that could dance with earthquakes. This is the story of how ancient Chinese architects defied physics and built without a single nail. We look at a skyscraper today, a monument of steel and glass, and we see strength in its rigidity. We see defiance. Its goal is to stand unmoving, to resist the forces of nature with pure, unyielding mass. It is a declaration of war against the elements. But the ancient Chinese architects saw the world through a different lens, one polished by Taoist and Confucian thought. Their philosophy wasn't about defiance, it was about harmony. They looked to the natural world for their lessons, not as a challenge to be overcome, but as a master to be emulated. They saw the tall, rigid tree snap in the typhoon while the flexible bamboo bent with the wind and survived. They observed that a stream doesn't fight the rock in its path. It simply flows around it, and in time, even wears the rock away. They understood that true resilience wasn't about being unbreakable. It was about being adaptable, about absorbing pressure rather than meeting it head-on. This core idea, this principle of yielding to overcome, is the secret key that unlocks the entire mystery. Their buildings weren't designed to be rigid sculptures of stone, eternal and cold. They were designed to be flexible skeletons of wood, organic structures, organisms that could sway, absorb and dissipate energy, that could breathe and settle and age with grace. And to create this, they developed a system of woodworking so precise, so sophisticated, that it feels less like carpentry and more like watchmaking on a monumental scale. It was a language of wood, a silent poetry of joinery where every element spoke to another. It all began with the most fundamental puzzle piece, the joint. At the heart of every great Chinese structure is a simple yet profound concept, the mortise-and-tenon. Imagine a wooden peg, perfectly carved on the end of a beam. This is the tenon. Now imagine a hole, meticulously chiseled into another piece of wood, designed to receive that peg with a snug, satisfying fit. This is the mortise. It's a handshake between two pieces of wood. A connection made with such precision that it needs no external fastener. It holds through friction, through geometry, through perfect alignment. But the ancient Chinese masters didn't stop at one type of handshake. They developed hundreds of different joints, a vast and secret language of wood, a catalog of connections for every conceivable force and angle. There were through tenons for sheer strength, dovetailed joints that locked tighter under tension, and mitre joints for elegant corners. Every connection in the entire building, from the mightiest column to the most delicate eave, was a variation of this core idea. The entire structure was one giant, three-dimensional puzzle, a masterpiece of geometric interdependence, and the first rule of the puzzle was that nothing was permanent. A damaged beam wasn't a catastrophe, it was a simple repair. You could disassemble the joint and replace the single piece without bringing down the entire house. This was architecture as a living, repairable system, a philosophy of sustainability and practical wisdom written in wood. It was built not for a lifetime, but for generations. But joints alone couldn't support the incredible weight of those iconic roofs. For that, they needed a masterpiece of engineering. They needed a cloud of wood to hold up the sky. They needed the dougong. Look up at the roof of any ancient Chinese temple and you will see it. A complex, beautiful cluster of wooden brackets blossoming out from the top of a column, looking almost like a wooden cloud or a botanical growth. This is the dougong, and it is perhaps the single greatest innovation in anti-seismic engineering in human history. The name tells you what it is. Du means block, and gong means arm. It's a system of interlocking wooden arms and blocks, layered together with a mesmerizing complexity, like a child's toy, but with the deadly serious purpose of holding up several tons of tile and timber. Its primary job is gravitational. It acts as a sophisticated transition, taking the enormous weight of the roof and transferring it outwards, from the column to the eaves, allowing for those dramatic, sweeping curves that define the skyline and protect the walls from rain. But its secret function, its true genius, is revealed only during an earthquake. When the earth trembles and shakes, a rigid building fights the force. It resists until it can resist no more, and then it shatters. But a building with dougong brackets does something extraordinary. It dances. The dozens of individual wooden pieces in the dougong cluster are not glued or nailed. They are simply fitted together. When seismic energy courses through the building, these pieces flex. They slide against each other. The friction between them absorbs the massive, destructive energy of the earthquake and dissipates it, converting a building-shattering shock into a gentle, rhythmic rocking motion. The entire structure sways as one unified organism. It doesn't fight the quake, it embraces it, moves with it, and survives it. The Sakyamuni Pagoda, a 67-meter tall wooden tower built in 1056 AD, has survived over 40 major earthquakes using this exact principle. It's a system so effective that modern engineers now study it to design base isolators for skyscrapers. But a flexible skeleton needs a special kind of foundation. And this is where the final, most counterintuitive secret comes into play. If you were to visit the Forbidden City and somehow lift one of the massive wooden columns, you would make a startling discovery. The column isn't buried deep in the ground. It isn't even firmly attached to its stone base. It just sits there. It is, for all intents and purposes, floating. This is not a mistake. It is by design. The stone base protects the wood from ground moisture, a simple but effective solution to rot. But its real purpose is far more brilliant. During an earthquake, this allows the entire wooden frame to shift and slide on its stone foundations. The energy of the quake is not transferred directly up into the rigid structure. Instead, the building skates on its base, moving as a whole and then settling back into place once the tremor has passed. The stone bases themselves are often deliberately polished smooth to facilitate this movement. It is a breathtakingly simple and brilliant solution, an ancient form of base isolation that we've only recently rediscovered. They understood that to survive a dynamic force, you must yourself become dynamic. And finally, we have the walls. When you look at a beautiful Chinese temple, you see elegant walls of brick or stone. You assume they are holding the building up. You are wrong. In a traditional timber frame structure, the walls are not load-bearing. They are merely infill panels, screens placed between the structural wooden columns. They bear no weight. This means that in a catastrophic earthquake, when the shaking becomes too violent, these walls are designed to fail. They will crumble and collapse, but in doing so, they absorb energy and, most importantly, they leave the primary wooden skeleton intact. The vital, flexible, life-saving frame remains standing, protecting anyone inside. They designed parts of the building to be sacrificed so that the whole could survive. It is a concept of astonishing strategic brilliance, a lesson in priorities that modern architecture is still learning. But this story isn't just about physics. It's about philosophy and a breathtakingly modern approach to logistics. This entire system was enabled by a revolutionary approach to construction, prefabrication, and modular design. Centuries before Henry Ford and the assembly line, Chinese builders were working from official government manuals like the Yingzhou Fashi from the Song dynasty that dictated standard sizes and dimensions for every single component. Every beam, every bracket, every column had a defined modular size based on a system of units. This meant that teams of craftsmen could be working miles apart in different workshops, manufacturing identical, interchangeable parts. The entire building could be pre-cut, numbered, and prepared off-site, and then assembled on location with astonishing speed and perfect accuracy, like a giant, life-sized puzzle. It was a system of efficiency and quality control that would not be out of place in a modern factory, ensuring imperial projects were completed to exacting standards across a vast empire. This modularity also reflects a deeper cosmic principle, a desire to mirror the order of the heavens on Earth. The buildings were often designed as microcosms of the universe, with their proportions and layouts reflecting celestial harmony and the Confucian social order. The dougong brackets, multiplying as they rose towards the roof, symbolized the expansion of the universe from a single point. The entire structure was a perfect balance of earthly practicality and celestial poetry, of geometry and philosophy fused into wood. So the next time you see a picture of the Forbidden City or a graceful pagoda silhouetted against the mountains, I want you to see more than just a beautiful building. See the invisible handshake of the mortise-and-tenon joints. See the complex cloud of the dougong, patiently waiting to absorb the next earthquake. See the floating columns, ready to skate on their stones. See the walls that are willing to sacrifice themselves for the greater good. This was not a primitive way of building. It was a profoundly advanced one, a path not taken by the West. They didn't have our materials, but they possessed a deeper, more nuanced understanding of the forces of nature. They knew that sometimes the strongest way to stand your ground is to know how to move with the flow. They built without nails not because they lacked the technology, but because they had discovered something better, something more elegant, and ultimately more resilient. They had discovered that true strength lies in connection, in flexibility, and in harmony. And in doing so, they created structures that have stood for 1,000 years, not as rigid monuments to human ego, but as graceful, breathing partners in a dance with time itself, whispering ancient secrets of resilience to those who know how to look.